James Webb was supposed to be the last word in space telescopes. NASA just finished building something that makes it look outdated, and it launches in 8 weeks. The James Webb Space Telescope cost $10 billion and took over a decade to build. It has photographed galaxies from the dawn of the universe. It rewrote everything astronomers thought they knew about how stars are born. And none of that prepared anyone for what NASA just rolled out of the clean room. The Nancy Grace Roman Space Telescope has a mirror smaller than Webb's. And it doesn't matter, because when it opens its eye in orbit, it will capture 100 times more sky in the same amount of time. But here's what almost every headline is still getting wrong. Roman was never built to outsee Webb. It was built to answer the one question Webb physically cannot ask. What is the universe actually made of? Because 95% of it, dark matter, dark energy, has never been directly measured. Not once. This is the story of the telescope built to finally look at everything, all at once. The Nancy Grace Roman Space Telescope carries a mirror 2.4 meters wide, the same size as Hubble's. Next to Webb's 6.5-meter mirror, that sounds almost modest. But Roman carries something Webb was never built for. A field of view 100 times wider. One single Roman image covers ground that would take Webb 100 separate pointings to photograph. Its camera holds 300 megapixels. One frame, and it captures a patch of sky larger than the full moon. Think of it this way: Webb is a microscope. Roman is a wide-angle lens photographing an entire city in one exposure. Webb tells you what one galaxy looks like in extraordinary detail. Roman tells you what 2 billion galaxies are doing all at once. Width versus depth. And that difference is everything, because the question Roman exists to answer cannot be answered by staring at one thing at a time. Here is the problem that makes Roman necessary. Astronomers look at galaxies, and the stars at the edges are moving too fast. The gravity of everything visible, stars, gas, dust, is not enough to hold them in place. By every law of physics, they should be flying apart. They are not. Something invisible is holding the whole structure together. That something is dark matter. It does not emit light. It does not absorb light. It has mass. It has gravity. And it makes up roughly 27% of everything that exists. Not one particle of it has ever been directly detected. Dark energy is stranger still. In 1998, astronomers discovered that the expansion of the universe is not slowing down. It is accelerating. Something is pushing space itself apart, faster and faster, overpowering gravity at cosmic scale. We call it dark energy. It accounts for 68% of the universe's total energy content. Add the two together. Dark matter plus dark energy equals 95% of everything that exists. The remaining 5% is every star, every planet, every galaxy, every atom, everything humanity has ever seen or measured. All of it is floating inside a universe we fundamentally cannot see. Dark matter explained and dark energy explained are phrases that already exist in thousands of videos online. But explained is generous. We know these things exist. We have no real idea what they are. Roman is the first instrument built specifically to measure them, not guess at them. Mass bends light. Einstein's general relativity predicted it, and astronomers confirmed it back in 1919. Massive objects curve space itself, and light bends along that curve. Dark matter carries no light of its own, but it has mass. Therefore, it distorts the shapes of galaxies behind it, subtly but measurably. Current surveys have mapped this effect across tens of millions of galaxies. Roman will do it for 2 billion. At that scale, the signal stops being subtle. It becomes unmistakable, a three-dimensional map of dark matter built directly from the light itself. For dark energy, Roman watches how fast the universe has expanded across 10 billion years of cosmic time, tracking exploding stars whose brightness never lies, and a rippling pattern in galaxy distribution left over from the early universe. Enough precision, finally, to answer whether dark energy has stayed constant or whether it is changing, which would mean physics needs a rewrite. Dark matter and dark energy are Roman's headline mission. They will not be what makes the most noise. While it hunts them, Roman will simultaneously watch 100 million stars near the galaxy's core, waiting for a brief flicker. A foreground object drifting in front of a background star, bending its light for a moment. If that foreground object has a planet, the planet leaves its own tiny signature inside that flicker. This technique finds planets that no other method can reach. Cold worlds, far from their stars, the kind that have barely been touched by any exoplanet survey to date. Roman's microlensing program alone is expected to add thousands of new worlds to the census, and finally answer how common a solar system like ours actually is. But here is the part almost no astronomer says out loud. The most important discovery an observatory makes is rarely the one it was built to find. Hubble was designed for cosmology. Its most cited legacy includes the first atmospheric readings of an exoplanet's chemistry and a complete rewrite of how galaxies form. Neither was in its original mission statement. Roman will point a 300-megapixel eye at a sky that has never been surveyed at this resolution, continuously, for 5 years minimum. Across a volume no ground or space telescope has ever covered. Something unexpected is not a possibility. It is close to a guarantee. The telescope is not named Nancy Grace Roman by accident. She joined NASA in 1959, becoming the agency's first chief of astronomy, the first woman to hold an executive science role there. Her actual job was managing research grants. What she really did was spend a decade building the case for a space telescope that did not yet exist anywhere except on paper. She left NASA in 1979, 11 years before that telescope finally launched as Hubble. She died in 2018, having watched the instrument she fought for become the most scientifically productive telescope in history. Her name on Roman is not ceremony. It is a continuation of the same bet that looking from above the atmosphere is always worth the cost. Roman completed final assembly in 2025. Since then, it has passed its last mirror inspection, and it is now being shipped from Maryland to Florida. Launch is confirmed for August 30th, 2026, aboard a SpaceX Falcon Heavy from Kennedy Space Center. Destination, the Sun-Earth L2 point, the exact same orbital neighborhood as James Webb, 1.5 million kilometers from home. 8 weeks, not 18 months, not 2027. 8 weeks from right now. By the time its primary mission ends, Roman is expected to map dark matter in 3 dimensions across billions of galaxies and pin down dark energy to a precision no survey has ever reached. The 2 open questions finally closed. Once it arrives, Webb will not go quiet. It will still be pointed at the single most interesting objects Roman's wide survey turns up, examining them with a depth Roman's own camera cannot match. Webb shows you one thing in extraordinary detail. Roman shows you everything, all at once. Roman finds, Webb looks. 2 instruments, doing separately what neither could do alone. James Webb was never outdated. It was just waiting for a partner wide enough to tell it where to look next. That partner launches in 8 weeks.